searching both
Ah,
was completed yesterday, no?
yes, yes.
So we will start from linear search
ये भी
efficiency.
हो गया था.
ये भी होगा तो pattern matching.
Ah, pattern match.
Pattern matching, string pattern matching. uh, Pattern matching, given string occurrence, find the aim is to find the position of the occurrence of the pattern. So this is our goal, है ना?
Okay.
So the
Hmm.
algorithm, pattern matching algorithm means string matching. You have to find a substring inside
Mm-hmm.
another string. Okay.
Okay.
So and if the string is found inside that string, bigger string, then you have to
Hmm.
return the position.
Hmm.
Okay. So brute force searching. Eh, ये तो एनिमेशन हो गया ना? Looking like animation.
Yes, yes.
अच्छा अच्छा. So pattern matching in brute force technique is basically, see, this is pattern matching. Just let me
कि
give.
एम क्या बताए थे यहाँ पे? Find the position of the substring.
Find the position of the search string. Suppose you have, so pattern matching, we can do pattern matching in many
Hmm.
different ways. Okay, but here we
Mm-hmm.
are applying the brute force technique. What
Okay.
is pattern matching? Basically, suppose uh, say Indonesia.
Hmm.
Okay, suppose this is a string
Hmm.
Indonesia. So maybe this is your, acha, they are taking uh, S. N is the length of the text, M is the length. Okay, S and P. So this is your S.
Hmm.
This is your S, and
Hmm.
P will be your maybe DON. Okay.
Hmm.
So if you want to find this
Hmm.
P,
Hmm.
if it is present in, if it is present in S. Okay.
Hmm.
Now we can clearly see that it is present in this S string now.
Hmm.
So we have
Yes.
to find the position. So what is the position? The first
0,
position is 0, the second position is
1,
1, the third one is
2.
sorry 2, then the 3. It's like array. Not like
Hmm.
array, it's basically an array. 4.
Hmm.
Okay. Say 5,
5.
6, 7 and 8. 6, 7
Hmm.
and 8. Okay. So these are the
Hmm.
positions. So here we can see our pattern is
Hmm.
present or is
Hmm.
started from position 2. So we will, this algo will return 2. Okay. So this is the aim.
Hmm.
Now how we do that? How to perform? Basically, it is very simple technique.
Hmm.
Say
Start searching from the first character.
start searching from the first Indonesia, right?
Hmm.
So we are searching D.
Hmm.
Just like that. Okay. So we are
Hmm.
searching D. If it match with the first element, then we will proceed.
Mm.
Since
Yes.
we are not able to find the match, so we move D here. Okay,
N will be compared.
it will be compared with N. Okay,
Mm.
since again it is not matching, so what we will do? We'll move to the next
Third
position. Here we found a matching.
matching.
Then we
Mm.
will match the next character or pattern with the respective
Okay.
character of the
Mm.
string.
Mm-hmm.
Since it is a matching, so we will consider the next character. And since here the pattern string
Mm.
finished, na, the
Yes.
pattern string is completed, so we are
Completed.
returning the position and
So
we'll
after finding the complete position, complete pattern matching, then it will return the position.
yeah, obviously. Okay, so this is your simple pattern matching algorithm in brute force technique.
Mm.
Let's look into their
Okay.
algorithm. So this is your first string and this is your pattern. So the length of the first string
Mm.
is n and the length of the pattern is your m. Means this array contains n number of characters and this array contains m number of character. Okay.
Mm.
So here, tell me how we will do that. We will start a loop from here. Na?
Yes.
We will start a loop from here and
Mm.
we also have to start a loop from for this string. So there will be
Mm.
a nested loop. This loop
Yes.
will comes into this loop. Okay. In
Mm.
this loop, say we set an index I. What they
Mm.
are taking I and they are taking
Mm.
J. Okay. So in this loop, they are taking I. They will start from I equal to 0 and it will go
0
up to the length.
minus 1 or the length. Okay.
Yeah. Again, for J, we will start from what? J equal to 0. For every time,
G.
it will start from J equal to 0 because we start from this location. This is J equal to 0, no? 0, 1, 2. So initially, we are matching with the 0th element of I
Mm.
and 0th element of Z.
Mm.
If it matches, then we increment the J only. See, first in first line, J, it is not matching with I. So we just break this loop. We have to break the inner loop
Okay.
and increment I. So I will be there, right? We
Mm.
are again comparing with the ith element and the jth element.
Mm.
Okay, so jth element will be again the 0th element.
Mm.
So this is not matching. So
Okay.
the loop
I
will
is
not enter into the
loop will
jth loop.
create. Mm. I is incremented
I
to the
will be
next
incrementing.
position.
Since there is a match with the
Mm.
0th element of this string and the ith
They
element
also
of
will
this
be.
string, we now just increment the j. J will come
Mm.
here. Okay, I will also increment it like that. Okay, so now see, there is one mm, point to discuss here.
Mm.
Since there is a match in this
Mm.
case, okay, it is a match. Now what
Mm.
you will do? If it is a match, then you have to compare these two. Now, now you can easily trace this character by using J++. It will be the next
Mm.
character in this loop, right?
Yes.
See, this loop will be your for I is equal to 0 to
0
n.
to length.
This loop will be your for j is equal to, just a minute, I'm writing this loop with this thing. So this inner loop will be your for j is equal to 0 to what? M,
To M.
right? But
Mm.
think, it is a match in the ith loop and jth loop. ith element of this string and jth element of this string. This is a match. Then what we will do?
Mm.
We will
To return the position.
iterate to this loop. This loop will iterate. Okay.
Mm.
The
You have to
control will
break
not.
the outer loop.
Sorry.
You have to break the outer loop or what?
No, no, no. Why? This outer loop will iterate for until we find a match or the string will
Mm.
end. Okay.
Mm.
This loop will iterate for this much of number of time. Okay.
Mm.
See, if there is a match, then we will increment j. J will be incremented obviously. Okay. So if you increment j, so this element can be traced. But how to get this element? Ith element, you cannot increment I value because I value will be incremented here, right?
Mm.
So what you will do? You get this point by having your I. Okay, by having the
Mm.
I inside this loop, you can point to this location. Okay,
Mm.
after that with I, if you plus j value, then you will get this the next element in the first loop. Are you getting the thing?
Mm.
Just let me show you. I think it is not clear. Indonesia and Dom, right?
Mm. No, I got it. I was just summing the value of I and j at this position. At this position, the I should have been gone to 2.
See here, this is your
0, 1,
0, 1, 2,
2.
3, 4, 5, 6, like that. Okay, and it is your 0,
Mm.
1, 2. So if this is your 2, then
Mm.
this I can say 2 plus 1.
Plus 1.
That means
Mm.
the this value, and this you
Mm.
can say 2 means the I. This is your I.
Mm.
Okay, 2 plus 2 means this one, respective position. Okay,
Okay, okay. I got the sum now. The proper. Got
because
it.
you
Right.
cannot increment I plus plus here inside this
Mm.
inner loop. You cannot do that. Okay, why you cannot do that? If you increment I, then suppose
The scope.
for
Mm.
DO it is matching, but the next element is not matching, then these two elements will be skipped for the next iteration.
Next iteration.
So you cannot increment the I. Okay.
Mm.
Okay. See what they are doing here. I equal to 0 to n minus m. N minus m. Why they are doing n minus m? Okay. Because see the length of dawn is 3. No?
Mm.
So it is sure that for Indonesia, anything after this location, we will
Mm.
not find a match. Okay. Because if you have Indo, say something A, C, say D, O. Okay. See here, since after this point, there is no
Mm.
possibility of matching with dawn because we do not have enough
3 letter here
character.
and it is only 2 characters.
Okay, so that's why this loop, since we are here writing from 0
So
to
straight
n,
away considering till
if
n, m minus n.
we can reduce this to n minus m.
Minus n.
Okay, so the number of iteration will be lesser.
Be less. Mm.
That's why it is m minus n, n minus m. Okay, no problem. Then
Okay.
j is equal to 1. Why j is equal to 1? They start comparing the ith element, okay,
Mm.
with the jth element. See here, if j is less than m, means this is the condition. This is the condition, this loop. Okay, so j will be less than, how many times this loop will iterate? It will iterate till j value is less than m. Now what is m? M is the length of the pattern, means our dawn. Okay, and they are providing this condition, this if condition. Okay,
Mm.
since they are using while loop, so what we in if you use for loop or anything, you can use if statement inside this loop, or you can
Mm.
club the condition along with this condition, the length condition. So what is the
Mm.
condition? See here, I plus j will be equal to jth element. Means the Indonesia, the string. This is, see,
Mm.
S. This is S, na? So
Mm.
S means the main string. So the
Mm.
I plus jth character of main string, if it is equal to the jth character, initially jth character is the first character of the mm, pattern string. If it matches, then move j plus 1. Means you increment the value of j.
J.
The next value of j will be your 2. So I plus j means the second element in the source string. Okay, in the main string, the second element from where the matches take place. That means DO
O.
will be matched with the second element of the pattern string. Right.
Mm.
So in this way, this loop will iterate for the here m length of time till the matches with the source string take place. Okay. Now
Okay.
what they are checking here, up, see here, this loop completes here now. Since we do not have
Mm.
the bracket, so this while loop will consider only this line. So after
Mm.
coming out of this loop, if we are getting that our j value is equal to m value, means what is the meaning of this line? Meaning of this line
Like.
is that we proceed this logic up
Mm.
to the last part of this one.
Mm.
Okay, means we get the full substring inside our source string. If
Mm.
this loop completely iterate, means up to m, that means what? Every match took place. Okay,
Search is found. Pattern search is found.
pattern is been found inside that source string. So this is the
Mm.
condition which actually identify, means this condition is actually identify whether the pattern is found inside the string.
Found or not. Mm.
Because see, when your j will be equal to 1, j will be equal to m. So j was
Mm.
started from 1. Okay,
Mm.
and after that it is entering inside a loop. Okay, and inside that loop j has been incremented just by 1. Coming out of the loop, you are taking that j is equal to m or not. If j is equal to 1, then if j is equal to m, that means this loop this loop iterates for m number of times, because j was started from 1 and here j is equal to m. So this loop iterates for m number of times, right?
Yes.
Now m number of times means what? The total pattern string
Length.
has been traversed. All
Mm.
the characters of the pattern string has been traversed. And with this condition, we have another condition here. It has been combined with AND operator. What is this condition? This condition is telling that every time, every character of this pattern string, while traversing, every character of this string is matched with every character of the source string, relative
Okay.
character, every relative character of the source string. That's why we have written here E equal to, double equal to. So this should be take place, है ना? This must be take
Ah,
place. If for some characters this is false, then j will not be incremented up to n.
implemented.
Okay, and once this condition for any single character, if it is get false, then at very next time it will come out of the loop, and j will not be incremented thereafter. So they can j cannot reach to m. Okay, that's why this condition, using this condition, we are actually getting that whether the pattern is been found inside the source string or not. If it is complicated, then you can use a flag variable. So whenever there is a match and you break this one with the loop here, with the if condition here.
Yes.
Okay, if you make this condition inside a if, and inside that whenever you get a this condition becomes true inside if, you are getting a flag value as 0 or 1, something like that. Okay, you can use a flag variable to break this condition here. Okay,
Okay.
now tell me, is it okay?
Yeah, this is fine.
Okay, so if this condition is true, then return the value of I. Why I? Because from ith position we actually started. See, after successful search, j will be up to here. Na? J will move to this position, but I will be there. I will be standing over there. Okay, so
Okay.
ith position is the position in the source string where the actual match was found. That's why they are returning the value of I. Okay, tell me, is it okay?
Yeah, it is fine.
Okay, now if say no match has been found, okay, so for some character this condition will not be true. Okay, this condition will be false. Since the condition become false for some characters, so j will not be incremented up to m. Okay, so if there is no match found, then this return statement will never occur. Now, are you getting it?
Yes.
If this statement never occur, then what will do? This for will be ended up one time. Okay, after this for stops iterating or exit, then what will we have here? We have -1, return -1. So if a match is found, if the pattern is
Then
found
the
in the
position
source
will be
string,
returned.
so this return will
I
take
position
place. If there is no match, then this
minus
return
one.
will take place. Okay,
Hmm.
so here in this return we return -1. Now -1 cannot be a place in the array because we know
Okay.
that array starts from 0. -1 cannot be a position. So the program that call this function, if it get -1, then it will understand, okay, match was not found.
Pattern is not there.
In other condition, if it is if that if there is a match, then obviously the value of I will be returned, and which will be a any value from 0 to n, right?
Yes.
Okay, so this is the algorithm. This is very simple algorithm. Best case analysis. Now, what is best case? The pattern is found at the very beginning, very first time, and means if it is, in our case, if it is do ne shi a. So we found don at the very first place, the beginning of the string. So this will be the best case, right?
Yes.
What will be the worst case? So we are founding don at the last three character. That will be the worst case.
Worst. Worst.
Worst case. And every other case is called average case. Okay.
Average.
So best case is your, what is the best case? They are saying
Omega.
omega of m.
Of
Omega means
M.
the lower bound. Okay.
We
Omega is
go
the lower
theta,
bound.
anything that you know.
Yeah. Best case analysis, you can say, uh, if the means since the pattern, we found the pattern at the very beginning. Okay.
Mm.
So the best case, you can represent the
Yes.
best case by big omega notation, big O notation, big theta notation. For any case, best case, worst case, and average case, you can represent them using any of the notation, big O, big omega, and big theta. Okay.
Okay.
So you can represent it big omega also. You can represent it big theta. Sorry, big O also. Now, if you want to represent some case with theta, then there will be some constraint. Okay. But in if you want to represent it with big omega and big O, then
Then it is same.
it is same. Okay.
Okay.
Okay, we can explain it while we will do the complexity analysis for different types of algorithm, probably in the next class. Okay. So now consider this one, worst case analysis. Worst case analysis means while the loop iterate for maximum number of time, right?
Mm.
What is worst case analysis in any algorithm? What is worst case analysis? Means
Which is
what is
taking
the
more
worst
time.
case?
Which is taking more time to complete the search or for.
Worst case means, I told you last day. Worst case means we are not finding, it's not unsuccessful search or unsuccessful matching. It is a
Mm.
successful matching, but we are getting it at the very last time, just before the
N
completion
you
of the
can tell,
algorithm.
huh?
Okay.
Omega N.
No, that was the case of linear search.
Okay.
Okay, that was the case of linear search. Now here you see, for any algorithm, if it is a iterative algorithm, means you have some loops in it. Okay,
Mm.
then the worst case, when you will find the worst case, when the loops goes for the maximum iteration,
Mm-hmm.
that is the worst case. Means the loop has been iterated for the maximum number of times to get the match. Okay, so that
Okay.
is the worst case. Now, if you consider that the loop goes for maximum number of times, then look at the algorithm. See here. So how many times this loop will iterate?
0 to N minus N.
0 to n minus m.
Mm.
So we can write here the time complexity will be sum of I is equal to 0 to n
M
minus
minus
m.
N.
But you have another loop inside it. Okay.
It is a J loop.
Here we are counting how many times this condition, this statement will iterate. Okay.
Mm.
We are not considering this line, we are not considering this line, because the
Mm.
innermost statement, how many times? Because the probability of executing most number of times, which statement? You have this statement, you have this statement, you have this statement, sorry, you have C, except the loops, you have
While
this one,
statement is
this one,
if
this one,
and
and
if.
this one. You have four
Yes.
statement except the these two loop statement.
Looping.
So
Mm.
you have four statements. J is equal to 1, J is equal to J plus 1, and this one. So among these four statement, which statement is
If
supposed to execute for maximum number of times?
J is equal to M.
If, where? Where you find if? No, not this one. The, sorry,
Oh, that one. J is equal to J. No, that not that
this
increment
one,
also.
this one. Because this
Increment.
is the innermost, means you have this loop, inside that you have another loop, inside that you have this statement. Okay. This
Okay.
statement is inside this loop, not inside this loop. Okay.
Mm.
So the chances for executing maximum number of times is this one. So
Inner loop statement.
we are interested to find how many times this statement will be executed. If we
Mm.
can find how many times this statement will be executed, that will be the time
What
complexity of this algorithm.
time codes?
Okay. So now see, for this loop, we can write this one, and for this loop, how many times it will iterate? It will iterate for j less than m. Okay,
Mm.
j less than n. See here, j is equal to 1 to n. So we can write sum j is equal to 1 to m. Okay.
Mm.
Uh, Sorry, where's the algorithm? Here. So inside this loop, how many statements are there? One statement.
Two. But one statement to be considered.
This is not inside this while
Okay.
loop.
100%. Sorry,
Okay.
sorry. This is
So
not there in the loop only.
just one statement. So you
Mm.
write 1 here. If you have two statement inside that innermost loop, you can write 2 here, 3 here. Okay. Just like that.
Mm.
Okay. Now how to expand it? I told you yesterday
Yes.
that upper limit minus lower limit by minus upper limit minus lower limit plus 1. Okay.
Okay. Mm.
You see it from here. See, m minus 1 plus 1.
Mm.
M is the upper limit. So m minus 1, 1 is the lower limit. Why it is appearing big number? That's why I do not like this Windows 10 and 11. They makes things means
Very often. It's too much shortcut for the user.
I do not require anything. Just give me a simple interface. Okay, so m minus n and plus 1. Okay, okay. They have given the formula. Upper limit minus
Yeah.
lower limit plus 1. Okay. So this has been expanded. Na? The second
Ah.
summation has been expanded here. So this minus 1 and plus 1 will be cancelled and you will have m. So I is equal to 0 to n minus m. Right?
Mm. Mm.
So how can you expand it? Tell me, how can you expand it? See
Little.
here, you do not have any I inside it.
Yes.
Sum of m, I is equal to 0 to n minus m.
Mm.
So consider that this n minus m is equal to 5.
Mm.
Then what will be the value of this total? I is equal
5
to 0.
minus 50.
No, suppose n minus m, the value of n minus m is 5.
Okay.
Then what will be the value of this one? See, sum of m means what? You have to add m for that much number of times. Sum of m. If I if I tell you sum of m for 2 times, then what will be the answer? M plus n. M plus m. That means 2m. Sum of m for 5 times, then what will be the answer? M plus m plus m plus m, 5m. Right?
Yes.
Like that, how many times this m will be summed up? M plus m plus m plus m. Like this, it will go for n minus m times starting from 0. 0 to n minus m times. This
Mm.
is the means explanation. See here. So how many times? This will be your okay. Mm, okay, okay. Just see. Here we get both are same. Okay. I is equal to 0 to n minus m, and you have m, right?
Yes.
So first I'm showing you what they have done here.
Mm.
So as the formula goes, upper bound minus lower bound plus 1, right?
Plus 1.
So upper bound minus lower bound means what? 0
0.
plus 1, right?
Mm.
So this will be the formula if it is 1, right?
Mm.
But if you have m here, then what you will do? You just write the m here. Okay.
Mm.
So what it is? It is it is m into n minus m plus 1, right?
Yes.
It's okay.
Mm.
Okay. Now see, if I can write the same thing in this way, 0 I is equal to 0 to n minus m and m. What is it? What it means? It means m plus m means you
Plus
have to sum m.
some. Yes. Still it is n minus m.
So m. Okay.
Mm.
This will be your 0th m.
Mm.
This will be your 1
1.
means the value of I. I'm
Ah.
just writing the value of I is equal to 0, 1, 2 up to this. This will be your n
And
minus
m.
m. Mth m. So
Mm.
what it is? So it is your means I can
n
say,
minus m.
see from here to here you have how many number of m? How many
M
number of
number
m?
of times.
Huh?
M number of times.
M number of times. So I can write n minus m of
Mm.
m. Can I write it?
Yes.
Starting from 1 to n minus m. So how many m's are there? N minus m number of m plus you have this m. Na?
Mm.
So if you take this m common, then what you will have? N minus m plus
My
1.
plus 1.
See, this is the same of this. Okay. This is
Just
the
2 minutes.
basic thing of
I'm
summing. Hmm?
making a note of this
What?
because there. I'm just making a note of this. Just give me 1 second.
Sure. Summation symbol, the meaning of summation symbol is to sum whatever they are in front
Okay.
of this symbol. Okay.
Okay.
Whatever they are in front of this symbol, you have to make a sum of all
Mm.
of this term. This is called term.
Mm.
And how many times? This is the lower bound and this is the upper
And
bound.
the upper bound.
This much number of times you have to sum this element.
Okay. Mm. Done.
Hmm. Then, okay, just a minute. Okay, so now see what is your TC? TC is your m into n minus
Minus
m
m
plus
plus
1. So if you multiply it, so what we will get? M n
n.
minus m square plus m. Okay,
Mm.
so what will be your time complexity here? See, the time complexity, the relation gives us three terms now.
Linear equation we have to do.
No, it is not linear equation. Uh,
So
the
that
thing,
square which be
thing
having the maximum.
I told you that to pick up the maximum, Right?
Maximum term.
But you cannot take this term here because you have the
With minus
negative
sign
sign.
for this.
Because whatever the term is, this will actually subtracted from the total value. Okay.
Hmm.
So which one you have to pick here? You have to pick here
Mn.
this one.
Hmm.
Okay, Mn. So you can consider this big O of Mn. Okay, see big O of Mn. Okay, tell
Hmm.
me if you get it.
Yes.
Why you are not getting the M square? Is it clear?
Yes, yes, I got it.
If it was
If it is
plus,
plus,
okay,
then it should
then we
be
have to
m
take
square.
M square. Okay, now there is one doubt will remain obviously because you have, see here, there are two terms, M and N.
Hmm.
Okay, if we can consider it, what I told you that if it was plus, then we will take M square. Maybe this is not true for every time. Why you know? Now see, what is M and what is N? What is your Mn and will be
Product of
your
m square.
what is your M square and what will be your Mn?
Mn.
Let's
Sometimes
calculate
this
for few
product
times.
might be bigger than m
No, no,
square.
no, not like that. You have to consider it. Yeah, what is N? N is the length of the source string. Suppose our source string is of length
5.
1, 2, 3, 8,
Uh,
9 characters. So it is 9 characters. M is your 3 characters, right? So
3 characters.
what is the value of M square?
It is 9.
9. And what is the value of Mn?
M
27.
will be 27.
27. So if your search string, okay, is
Hmm.
of length this, and you know
Hmm.
that here M will always be less than equal to N. Na? M is always be less than equal to N because N is the pattern string. A pattern
Hmm.
string must be less than equal to
Lesser than the
length of the pattern string
searching.
must be less than equal to the source string because we are
Hmm.
searching pattern inside the source string. So the source
Hmm.
string must be length of the source string must be bigger. है ना?
Hmm. Huh.
So take some other, suppose n is 9 and the search string is 8
Also 9.
or 8. So this is
Hmm.
your 81. Sorry,
81.
no, this is your 64 now. This is your 60,
8.
m square.
8 is
M
64
square
and this will be 72.
72. So here also your we are taking the maximum. Okay,
Hmm.
9, 9. Here also it will be 81 and 81. So in all case, you see that your m square is less than mn. So
Hmm.
even if it is a
If it is
plus sign,
plus,
we have to take this one.
a product M and N.
Are you getting the thing?
Hmm.
So this will be true to picking up the maximum. Okay, if every element has the same letter. Okay,
Got
suppose
it.
it is your 2m and
I
this is
got it.
your some things, then you can consider the maximum power element. Okay,
Hmm.
okay. So this was your pattern
Pattern
matching
searching.
and the average case when the most shift after what is when there can be most shift after every few comparison is to be a linear. What is that? I'm not understanding this sentence. The average case is when there can be most shift after every few comparison.
is to be linear.
and is to be a linear. It will be linear. Okay, no problem. N plus m. Okay, if it is n plus m, then I can take the maximum value of n and m. Okay,
Hmm.
what is the maximum value of n and m? Obviously, it will be m.
Length of the source string and length of the substring.
No, so which one is bigger among m and n?
Bigger will be the source one always,
N,
obviously.
that is n. That's
Then.
why we can take big O of n or theta.
Hmm.
Okay, but I am not able to understand this sentence. Anyway, the average case is your theta of n.
Theta of n.
Average case is what? I told you the best case means the string will be present at the very beginning. The worst case, the string will be at the very last. Okay. What is the average case? All other
In
cases.
between
In
all
between.
other cases.
Okay. In all other cases, you will have to search this loop not for the maximum number of times. Okay. Sorry. This loop will be iterated for maximum number of times,
Hmm.
but this loop will not go to the maximum, right?
Yes, yes.
Okay. So you understand now? This loop will go for maximum
Yeah,
number
I
of
got it.
times,
Always, yes. For
but this
one
loop,
iteration of I,
hmm,
the J will loop will go from M to
1 to
so
m,
whatever.
1 to m. So
1 to
why
M.
I am telling that this loop will iterate most number of time, because the string need to be matched in between
Hmm.
place. But whenever there is a match, this will return. At once this will return. So the next iteration for this loop will not take place. Okay.
Yes.
So
That is getting reduced.
yeah, so some of the iteration of this loop we do not have to
Say for
consider.
example, in Dawn, that I was not executed for 2 times.
Aha. So no, I will be executed for some number of times. But how
Some
many
number
number
of
of
times,
times
but
we
it
do
was
not know.
less compared to J loop for 2 times, right?
Yeah. So for every iteration, this loop, okay, since we are considering that the match is will take place inside the source string, so
Hmm.
this loop will every time this loop will iterate for m number of times. See, m number of times. Okay, this
Yes.
will iterate for m number of times. Okay,
Yes.
now how many number of times this loop will iterate, that we don't know. It may iterate for, since it is not the best case, it may iterate for up to, means it may iterate for 2 times, 3 times, 4 times, but not the n minus mth time, because if it iterates for n minus mth time, then it will be the worst case. If it
Hmm.
is iterate for 1 time, then it is the best
Then
case.
it is the best case.
Okay, that's why they are saying that it is theta of n plus m. Okay,
Hmm.
and theta of n plus m, obviously theta n, because among n and m, n
N,
is the
N is
maximum.
the maximum.
Any doubts? What is this? Any doubt?
In between, they have they
Okay.
have inserted one. They have taken one break for that to check whether
Now, up to
student.
this, the PPT is not too bad, It's okay.
Okay.
Good. At least it is better from the last semester PPTs. There are so many errors. No,
If this.
PPTs were there. I think was
Mm,
not so bad. The SLM was there.
mm,
SLM was not very good. Okay, it's okay. Then we move to the exhaustive search. Okay, you have some exhaustive search. Inside exhaustive search, this is also a brute force technique. Exhaustive. Inside exhaustive search, you have traveling salesman problem, knapsack problem, and assignment problem. Just quickly go through it, huh? Traveling salesman problem. Now, what is a traveling salesman problem? Traveling salesman problem, I told you earlier that a salesman,
When he's going like.
yeah, a salesman will move around the city, okay, at different places. Maybe a dealer
Mm,
is planning to move its salesman to different retailers, okay.
mm,
So in the dealer must fix their routes, okay, in order to maximize the profit. Means what is maximization and minimization problem? We did that in our
and-
MHCA classes last semester. Okay, so this is basically traveling salesman problem. This is basically maximization minimization problem. So
mm,
means the dealer wants to maximize his profit in order
mm.
to minimize the time taken by the salesman to travel to all the dealers.
City.
Sorry, all the retailers. Okay.
Mm.
So she just give me a half minute. I'm just
Okay.
coming. Hello.
I'm there.
Mm. So you are understanding now what is
Yes.
traveling salesman problem?
Mm,
You are moving your salesman throughout the city at different points. Okay. If you are a dealer, so you have to supply your materials to different retailers. So you have to
mm,
move your truck or the salesman at
mm,
different places in the city,
mm.
and from one place to another place there may be different paths. Okay,
To
so
be chosen, to be taken.
different paths will have different cost of traveling, no?
Mm,
Maybe the distance, maybe the mm, fare, traveling fare, okay, you have to consider. So you have to find, the job is to find the shortest path, or a path along which if the salesman travels, then the cost will be become minimum. Okay,
mm.
if the cost goes minimum, then the profit for the dealer get
Will
maximized.
be maximized.
So this is the mm, problem of traveling salesman problem is, we have to find a path which contains minimum weightage. Okay,
Mm.
Hamiltonian circuit. Okay, Hamiltonian circuit is basically graph theory. You remember Hamiltonian circuit? I don't
Yes.
think that Hamiltonian circuit was there. Okay, now Hamiltonian circuit should be there. Eulerian graph, Hamiltonian path was there.
In
Hamiltonian circuit.
assignment problem, this kind of one word was there.
No, graph theory. It was not
Crafty.
there in assignment problem. It was there in graph theory. Hamiltonian circuit is basically a circuit. Okay,
Okay.
uh, where every node of a graph, you understand the node, no? These
Yes, yes.
circles are nodes, and these are the path, and this is the
ABCD is
weighted
notes
path.
and then
Yeah, vertices, you can say also vertex and the
ah
edges.
yes.
Okay, so Hamiltonian circuit is basically that circuit where every node will exactly traversed once. Means you cannot repeat the nodes twice. Okay, like
Mm-hmm.
A, B, D, C, A. Since this is a circuit, then you have to, since this is a circuit, so we have to reach to the initial point.
Mm.
If it is not a circuit, if it is a path, Hamiltonian path, then A, B, D, C, that will become a Hamiltonian path.
Mm-hmm.
Since it is mentioned that Hamiltonian circuit, so what will be the Hamiltonian circuit? A, B, D, C, A. You have to
Mm.
reach to the first node. Okay, so this is a Hamiltonian circuit. Again, this is another Hamiltonian circuit. A, D, B, C, A. This one
Mm.
is again an Hamiltonian circuit. Okay, but this
Okay.
is not a Hamiltonian circuit. See, A, B, C, A, D, and again A, maybe, or again from D to B to A, because A is been repeated and B is been repeated for more than once. So that will not be a circuit, Hamiltonian circuit. Obviously, that is circuit, but that is not a Hamiltonian circuit.
Simultaneous
The
circuit.
constraint for Hamiltonian circuit is that you cannot traverse the nodes more than once,
More than once. Okay.
but you can traverse the edges for more than once. That will not be the
Mm-hmm.
problem. So that is your Hamiltonian circuit and Hamiltonian
Ah.
path. Okay. So how to find the traveling salesman problem? See, this is not the best mm, algorithm to find the traveling salesman problem. We have more sophisticated algorithms for it. Okay. But in brute
Mm.
force technique, traveling salesman problem, we are finding a feasible solution. I told you
So what
this.
is this? Sorry, here I had a question.
Hmm.
It is also a technique comes under brute force, huh?
Hmm.
So
No,
this
it
is
is it is not a
exhaustive.
take. Sorry. Brute force is the technique. Traveling
Okay.
salesman problem is the problem. We
Okay.
apply the techniques to the problem for getting the solution.
Hmm. This
So
exhaustive search is what algorithm, huh? Or
exhaustive
data?
search means uh, for any kind of means exhaustive means what? You have to search for a solution. Means you are
Mm-hmm.
mad to find a solution. If there is a solution, you take it. You are not thinking about the best solution. Okay, you are mad about
Okay.
finding a solution. If there is a solution, you are taking it. You are not thinking about the best or
Okay.
means
Okay.
the efficiency of the solution. Whether it is the
Okay.
best solution or the worst solution, you are not thinking of. It is a solution.
Mm-hmm.
Okay, take it. Okay,
Okay.
and you are finding the solution by any means.
Mm-hmm.
That's why it is called exhaustive search. Okay, and you cannot compare it with a linear search and binary search.
Okay.
Those are excluded. In linear search means you are there is a pattern. You have to proceed in that way. That's why that is called a linear search. Here, this is not linear search. You are finding every possible options to get one solution. If there is a solution, you are taking. Okay, like that.
Mm-hmm.
So traveling salesman problem is something like that. So how can you perform the exhaustive search for traveling salesman problem using brute force? Now you compute every possibility, every circuit here, and find the sum of means the cost for every option. Means you have the circuit like that A, B, D, C, A. So what will be the cost? 2 plus 4 plus 7 plus 8. Okay,
21.
whatever. So in that way, you find every possible Hamiltonian circuit and find the cost. Okay, and
Mm.
you can take the minimum one.
Mm.
You take the minimum. See, they are showing here. So these are the cost. Okay, so this is the minimum cost. Huh?
Mm.
So you can
7.
take any one of
Two
them.
times it is there, so whichever it is.
Mm. Now see, these are the
Because it's
minimum
again
value.
vice versa only, I think.
Huh?
I think it is vice versa. They're reaching
Huh.
back once again to A.
Yeah, yeah, it is vice versa. Okay, see here, this is the minimum cost, so you are taking minimum. But how are you getting the minimum cost of circuit? You are checking every possible options. Now, that's why it is called
Mm.
exhaustive. In some more sophisticated algorithm, we do not have to consider all these checkings. Okay,
Uh-huh.
That's why it is called exhaustive search. Exhaustive search.
Okay.
Okay, solution is this. So the total number of permutations required is n minus 1 factorial by 2. Why? N minus 1 factorial by 2? Because you have n number of vertices. Okay.
Mm.
For n number of vertices, now think about the mm, permutation chapter of MFCA. If
Mm.
you have n numbers and you have to find every possible permutation of the n numbers, then how many permutations will you have?
N minus 1 factorial.
N minus 1 factorial. Okay. Or you can say n factorial. Okay.
Mm.
So you are considering every possible options,
Options.
every possible combination. Okay. So the
Mm.
total number of permutations is required factorial n minus 1 divided by 2. Now why divided by 2? Because see,
All the options are get repeating minimum 2 times.
so look here, how many nodes are there? It is
4.
1, 2, 3, 4. So 4 factorial, 4 minus 1. 4 minus 1 means 3. 3 factorial means 6.
Mm.
Okay. So you have 6 number of comparison. Sorry, 6 number of permutations. Here
Mm.
we have 6 number of permutations
Mm.
divided by 2.
Here that again 2 times everything is repeating.
Hmm.
20 is repeated for twice, 21 is repeated for twice, 17 is repeated for twice.
Look here, A, B, D, C, A, and it is A, B, D, C, A. Why
Mm.
we are getting it? Because see here, if you start from, just a minute, if you start from A,
Mm.
okay, if you move in
A.
this direction,
Mm.
okay, you can also move in this direction too.
It is one and the same.
The same, the sum will also be remain same,
That is the reason we are getting 2
divided
for
by 2.
pair of this thing. So
Divided
2
by 2.
is
This
divisible.
divided by 2 is for that reason. Okay.
Mm.
Now this will not be the case for every time because it is a undirected graph. Okay.
Mm.
If there is a
It can
constraint,
travel in both the direction.
yeah, that's why this can be divided by 2. But for complexity analysis, this 2 is a constant. So altogether, these 2 can be ignored also.
Ignore.
Okay. बस और कुछ नहीं दिए.
Mm.
Okay, they do not provide the pseudocode or the algorithm, just explanation. Okay, fine, no
हाँ.
problem. That is more easier to remember. Okay, if you remember the logic of traveling salesman problem, means you have to perform every combination, then find out the
Yes.
minimum one. Okay,
Okay.
okay. Oh, okay. Though so they are not giving the pseudocode for this one. Means the algorithm actually. They are
हाँ.
describing. This is actually a problem definition. What is actually
Mm.
salesman problem is.
Mm.
Okay, fine. Next is your knapsack problem. Zero
Mm.
one knapsack problem. You have two kinds of knapsack problem. You know, one is your zero one, another is your fractional knapsack problem. This zero one knapsack problem is sometimes it is called also as binary knapsack problem.
Mm.
Did they mention here? I don't know. Okay. So what is a knapsack problem basically is? What is a knapsack? Knapsack is basically, I told you last day, uh,
Yes.
it is the bag of a thief. Suppose
Mm.
a thief is there
He's
and
taking a
he's
big this thing with a
uh,
less value,
uh, while he
or
is in
a
his job,
small
he
item
must
with
have
a
a bag.
high value.
He must have a bag now.
Mm.
While the thief in his job, okay, so he must have
Mm.
a bag. And what is his aim? What will be his aim? His aim
Mm.
is to maximize his profit, okay, by pouring
Ah.
the bag, the precious
Mm.
elements inside it, okay. So his aim uh, will be to take, will be to means fill up the bag with maximum, okay, profit, okay. So this will be the aim of knapsack problem. Now here you see the maximum capacity of his bag is W. This is the weight. Okay. Suppose he is taking a bag which can take up to 50 kg of weight. Okay.
Yes.
And he needs to take the elements
Mm.
and put it inside the bag. The maximum capacity of the bag is W. Say W kg. Okay.
Mm.
And while he is inside a house, he is finding in items over there. Okay,
Mm.
so it is a set of in items. You have to pick up in items among a set. The set is containing in items. Sorry, you do not have to pick up all in items. You have to select
Mm.
some items from the in items so that
Mm.
the maximum capacity is less equal to W. So each of the item of these in items have a
Mm.
weight. Let's the weight is Wi. Okay,
Mm.
and each of the item has some value, so that is
Mm.
Vi. So ith element among these n all elements, all n elements, the ith
Mm.
element has the weight Wi and the value Vi. Okay,
Okay.
inside the house maybe there are 10 elements. First is
Mm.
your mobile, another is your TV, say fridge, okay, say some utensils, okay. So each of the item have some weight and some
Weight and
value.
value.
So the thief needs to select which item he will pick up and put it inside the bag so that no place in the bag will remain empty, but the profit is gaining most.
Mm.
Okay, so this is the problem. This is the problem. Okay,
Okay.
okay. So they are giving you an example, very good thing. So maximum capacity is W20. W is 20. Say this is a bag, this is the bag. So it can contain up to 20 kg. Okay. Now these are all the items. These are all the items. The first item, how many items are there? One, two, three, four, five. Okay. So there are five items, and the weight of the five items are like that: 2 kg, 3 kg, 4 kg, 5 kg. So this is a proportional ratio. They are showing the items. Okay. This is the biggest item. Okay. This is the biggest item. See, the weight of this item is 9 kg. So if the thief choice this item, okay, and put it inside the bag, so from 20 kg, 9 kg will be reserved. Okay. So what I was telling you, that these are the items, okay? There are five
Okay.
items. So this
Mm.
is the weight of each item, and this is the
Yes.
proportional figure. So suppose the
Okay.
thief is selecting this item. So
Mm.
as if he select this item and put it inside the bag, so among this, out of this 20 kg, 9 kg will be occupied, right?
Yes. The meaning will be only 11 kgs.
So the remaining 11 kg he needs to fill with these elements. Okay.
Mm.
So now see, these are the values of these items. Means this
Mm.
item cost 10, 10 rupees.
Mm.
This item cost 8 rupees. Okay.
Mm.
So how the person will take from these items, okay, how the
Mm.
person will select from these items to put it inside the bag so that the total weight do not
Should be
exceed
less.
20.
More than. Mm.
He cannot take the all these items because 9 plus 5 plus 4 plus 3 plus 2 is more than 20. Okay,
Yes.
so he cannot take all the items. He needs to select, he needs to pick so that the profit get maximized. Okay, now see, this is 01 knapsack. Now what is
Mm.
01 knapsack? 01 knapsack means you can either select an element or not select. You cannot take
Mm.
any part of it.
Mm.
Means the thief is also finding one big bag of rice. Now
Mm.
currently in India, our rice price of our rice is get increased. No?
Ha.
So he thought that I am going to take uh, 10 kg of rice out of that.
Mm.
Okay, the big bag contains say 1 quintal of rice. Okay, 100 kgs of rice. So
Mm.
he is planning that I am taking 10 kg of rice
10
from it.
sort of
But this
price.
will not be
Mm.
the case of 01 knapsack. In 01
Mm.
knapsack, it is telling that if you want to take the rice, then you have to take the full bag, means
Whole bag.
100 kg.
Container. Full
Otherwise,
10,
we
100
cannot
kg.
take. Okay, so mm, fractional knapsack problem is that
Oh,
where you
which
can
will
take
allow us to take a part of it.
part of it. That is the difference between fractional knapsack and 01 knapsack.
Okay, okay, got it.
Okay, so in 01 knapsack, this is also called binary knapsack. Either you take the whole or you do not
Whole
take it.
thing or nothing. Okay.
So how can he select to get the maximize?
Mm-hmm.
um, Problem in other words. Oh, they are again defining the problem. To maximize sum of pi. You
Why
understand
for
this?
the previous one they did not take and for this one they are taking?
What?
That this summation, the problem.
Summation is not the case of bothering. You have to understand why they, what they are actually trying to say here. This is
Mm.
the definition of problem. This is not any, not the case
Oh,
of time
there is no
complexity.
solution, proving or solution for this.
This is not time complexity. This is the definition.
Mm.
Definition of yeah, the knapsack problem is to maximize the sum of vi means what? Vi is what? Vi is the value of each
Value,
individual
value of an
value of
item.
ith element. Okay.
Mm.
So to maximize the sum of the values of all selected items,
Mm.
subject to sum of all the selected item, sorry, sum of the weight of all the selected item must be less than equal to W. W is what?
Container of that
W is
container,
the weight of the container.
weight
So
of the
this is
container.
basically the problem definition. Okay.
Okay, got it. Mm.
The summation you find here is not like that. Okay, wherever
What we
you got
calculated for
summation,
the time
it is a
complexity.
time complexity. No, no, no. This is the problem definition of knapsack problem. Okay.
Okay, fine.
Okay.
Here they've written a problem in other words.
Given n items, again they are defining. Okay, no problem. They are giving,
This is understood. This example is understood.
but where is the solution? Here is the solution. Okay. Okay, so they are not providing solution here for this problem. They are taking this problem and they are finding the solution of this problem. Okay, so how can you solve it? In brute force, see, There is a method of knapsack problem, probably in divide and conquer approach. Okay, sorry,
Oh.
greedy method. In greedy method, you have again knapsack problem. Okay, but in
Mm-hmm.
brute force method, you have to combine each and every element to see
From with the different combination.
what is the maximum value of profit. Okay,
Mm.
so here they are taking the combination. See, each individual item they are trying to find. So this is they are taking first item and second item, this one. First item, second item, third item, this one. Is something like that. They are finding every
Checking all.
combination, every combination. Okay.
Mm.
So if there are four items, okay.
Mm.
So how many checking it has to make?
4
It has to
into
no, not four into. Every item can be checked for twice, at least twice. Either take whether we take it or not take it.
or not take it. 0 or
Selecting an
1.
item is a check. Not selecting an item is also a check. So for each
Correct.
and every item, you have to check twice. So it will be 2 to the power 4 number
Mm.
of checking. Okay.
Mm.
Are you getting it?
Yes, yes, I got it.
Okay. So when you get all values, all combinations, then find the maximum value out of it.
Okay.
Okay. So that is the case of knapsack problem.
Mm.
This procedure considered the subset of, okay, no problem. This is the way of finding an optimal solution. Okay. Find the most valuable subset. So which one is your most valuable subset? You have to consider it from here. So I'm finding it 80.
Say what?
80. So it
Mm.
will take 2, 3. Okay. But this can be determined after making
All
combination of
the
all items.
checking, all the combinations.
Since there are n items, there are 2 to the power n possible combination of items, right? Thus the
Yes.
running time will be big O of 2 to the power n. This is a huge time taking complexity. 2 to the power n
Mm.
means mm, this is too much
Very.
of time. In fact, this is the most uh, time in order to time complexity. Okay,
Mm.
this is the most time. Means the maximum amount of time that can take an algorithm. 2 to the power n, like this.
Yes.
3 to the power n. Okay, something like that. Means m to the power n. If your
Mm.
complexity comes like m to the power n, where n
Mm.
is the number of items, then this is the biggest time of all times. Okay.
Mm.
Anyway, 2 to the power n is bigger than, means in time complexity 2 to the power n is much bigger than n to the power, say, maybe 100 or 10
Yes.
n to the power n. Okay,
Mm.
this is much bigger. So this is a mm, very big amount of time.
Okay.
Okay, so this is completed knapsack problem. Backtracking and branch and bound. Greedy method they did not mention. Anyway, so backtracking and
We'll have this in the next class.
branch and bound are
Sort.
two other technique through which the knapsack problem can be solved. Okay, and those
Okay.
will be your solve this problem in less than exponential time. There are some big
Okay.
terms here: NP hard and NP hard problems. There is another one, NP complete problem. NP means non-polynomial time. See, we will discuss it in our next class, NP or the polynomial, non-polynomial. Say, until this, we found something complexity in terms of n, na? Either n square or log n
Yes.
or something, say,
Yes.
n factorial. Okay, so all these types
Mm.
of functions are called polynomial functions. Polynomial for on n. Okay.
More than.
So if the time comes with polynomial notation, then we say that this is a p problem, means polynomial problem. Okay.
Mm-hmm.
And if the term is not coming in terms of uh,
Polynomial.
polynomial, okay, so those are called non-polynomial problems. And non-polynomial problems can be again divided into undeterministic or non-deterministic, NP-hard problems,
Mm-hmm.
those kind of problem for which the exact complexity cannot be determined by any times. That is called non-deterministic
Okay.
polynomial time problem. Those are big
Mm-hmm.
terms. For the time being, we keep those things separate. So what they are
Okay.
trying to mention here, this knapsack problem is a NP-hard problem, means it is taking the time taken by the algorithm cannot be determined straightforward. Okay, you
Mm.
cannot say that this will be the maximum time the knapsack problem will take. This will be the minimum time the knapsack problem will take. That cannot be determined.
Best case and worst case is
That's why
difficult.
it is called NP-hard problem. Okay,
Mm-hmm.
they are saying that this brute force technique, using this brute force technique, we will not find any specific time complexity. Okay, we
Mm-hmm.
will not be able to tell that this will be the time complexity, best case, worst case, something like that. But
Mm-hmm.
with some other technique like this, we can find a better solution, okay,
Mm-hmm.
which is less than exponential time. I told you that exponential time, this 2 to the power n or 3 to the power n or 4 to the power n, this is much, much, much bigger than the polynomial times. Okay,
Okay.
so in this type of techniques, our aim will be to reduce the time from exponential time, means from 2 to the power n time, to
Into
some
and
polynomial time, known time, that is n squared or maybe n cube, n to the power something. Even that will
okay.
be smaller time than 2 to the power n. Okay,
Yes.
so any algorithm comes with exponential time is
Mm.
not be taken.
Non-polynomial and
It,
it
it
is a
need to be
non-determined or something, no?
non-deterministic. Okay.
Not determined. Mm.
Okay, so these two technique will be there in later units, I hope. There we will
Yeah.
see how this time can be reduced to from exponential time to polynomial time.
Okay.
Job assignment problem. See, this is over 9.
MFCA. Uh,
So what you will do? Leave it for today.
yeah, we'll leave it for today because I have little extra work to continue for
Yeah,
tomorrow's
that.
preparation to be done.
Hmm. We will do it the rest of the part in Sunday, on Sunday.
Ah, Sunday